In this simple math lesson, we're going to take another look at some compound inequalities. We'll look at special situations that sometimes arise, as well as further exploring how the use of the words and or affect solution sets. Let's go ahead and get started. In this first example, we've got two inequalities connected with the word and, so we need to find values of x which satisfy both equations at the same time. As we've done in the past, we'll first solve each inequality separately. Let's start on the left. By adding 3 to both sides and then dividing by 4, we end up with x is greater than 3. Now let's solve the inequality on the right. Here we'll subtract 10 from both sides and then divide by -3 to get x is less than or equal to 6. Don't forget to switch the direction of the sign because we divided by a negative number. Next, we'll combine these two ranges of values into our solution set. To do that, let's look at them separately on a number line. First, I'll add our numbers 3 and 6 to the number line. Then let's draw our values in blue. X is greater than 3. We use an open circle to show that x can't equal 3, and then draw our arrow to the right. To draw the values in green, x is less than or equal to 6, we use a closed circle to show that x can equal 6, and then draw the arrow to the left. Okay, now we just need to find the area where both of these arrows overlap, and that is between 3 and 6. Finally, let's draw that overlapping area on our number line. We use an open circle at 3 and a closed circle at 6, and then shade in the area in between the two circles. Let's also write our solution set using inequality notation and interval notation. First, in inequality notation, we write 3 is less than x, which is less than or equal to 6. Next, in interval notation, we write our lower bound 3 with parentheses because x can't equal 3, and then we write our upper bound 6 with a square bracket because x can equal 6. This should look familiar as it's a similar problem to one of the examples we did in the first compound inequalities video. But let's see what happens when we leave everything the same, but instead of using and, we connect our inequalities with the word or. Well, now instead of needing values of x that satisfy both equations, we only need values of x that satisfy at least one equation. Now we can use any part of the number line that is covered by an arrow. We don't need to just find the area where the arrows overlap. Well, you can see that the blue arrow covers all values greater than 3, and the green arrow covers all values less than or equal to 6. So you can easily see that all numbers on the number line are acceptable. This means that the solution set is all real numbers, and we can use any value for x. To draw our solution set, we simply draw an arrow from left to right, which covers the entire number line. Now to write all real numbers using inequality notation, we write -infinity is less than x, which is less than infinity. Likewise, for interval notation, we use parentheses with -infinity on the left, and then we use infinity also with parentheses on the right. Using -infinity on the left tells us that there is no lower bound for x, meaning there is no minimum value for x. And using positive infinity on the right tells us that there is no upper bound for x, meaning there is no maximum value for x. Finally, remember that infinity isn't an actual number, so x can never equal infinity. That's why we don't write any equal signs when using inequality notation, and also why we use parentheses when using interval notation. Let's go ahead and take a look at another example. This time we're going to start with a compound inequality that uses or to connect our two individual inequalities. We'll go through the same process of solving each inequality separately. First, on the left, we'll subtract 12 from both sides and then divide by 5 to get x is less than -1. Then on the right, we'll add 15 to both sides and divide by 9 to get x is greater than 10. Let's go ahead and add our numbers to our number line and then draw each range of values to help us come up with the solution set. For x is less than -1, we draw an open circle at -1 and then an arrow to the left. For x is greater than 10, we draw an open circle at 10 and then an arrow to the right. You can easily see there is no area where the arrows overlap, but because we're using the word or to connect our inequalities, that's okay. Our solution set will include any values which lie under either the blue or the green arrow. So we can simply copy these arrows onto the number line to get the solution set for this compound inequality. Let's go ahead and write that solution set out. we get x is less than -1 or x is greater than 10. And in interval notation, we'll also write each interval separately. First, for x is less than -1, we once again use negative infinity to show there's no lower bound, and then we have an upper bound of -1, and we write that with parentheses. Then for x is greater than 10, we write our lower bound of 10 with parentheses, and then we use positive infinity to show there's no upper bound. Finally, we need a way to show that we can use values from either interval. To do that, we use a special symbol seen here. It's called union, and it simply means or. If you've studied set theory before, then this should be familiar. But if you haven't studied set theory, then this symbol will be new to you. But all you need to remember is that you use this U-shaped symbol in place of the word or when writing your solution sets in interval notation. Okay, now let's take a look at these same inequalities, but let's change or to and see what happens. Well, now we need values of x that satisfy both inequalities at the same time. And if you look at the arrows above the number line, you can easily see there is no area where the two arrows overlap. This means there is no value of x that will satisfy both equations at the same time. When this happens, we have no solution. To give your answer, leave the number line blank and write no solution. You'll also write no solution if you're writing it in inequality notation or interval notation. Now let's look at one last example. For this problem, we've got two inequalities connected with the word and, so we're looking for values that satisfy both inequalities. We'll solve the inequality on the left by subtracting 2 from both sides and then dividing by 3 to get x is less than 4. To solve the inequality on the right, we subtract 8 from both sides and then divide by -7 to get x is less than or equal to 9. Again, don't forget to switch the direction of the sign. Okay, let's add our numbers to the number line and draw the arrows. First, we've got x is less than 4, so we draw an open circle at 4 and then an arrow to the left. Then we've got x is less than or equal to 9, so we draw a closed circle at 9, and we also draw an arrow to the left. So now you can see we've got a situation that is slightly different from the problems we've looked at before. In all the problems we've already done, the arrows were always pointing in opposite directions, but this time they're pointing in the same direction. Well, we still go through the same process that we've gone through with all the other examples. The inequalities are connected with and, so we need to find the area where the two arrows overlap, which is here, to the left of 4. And this should make sense because obviously any number that is less than 4 is also less than 9. For our inequality on the left, x can't equal 4. So for our solution set, we draw an open circle at 4 and then an arrow to the left. But now you're hopefully pretty good at writing your solution sets in both inequality notation and interval notation. So for this solution set, we write x is less than 4, and in interval notation, we use negative infinity because there is no lower bound, and our upper bound is 4. And lastly, let's see again what happens when we change and to or. Well, as before, now we can use any number on the number line that has at least one arrow above it. So the solution set will expand from x less than 4 to also include this area under the green arrow up to 9, and also including 9. So we draw a closed circle at 9 and then an arrow to the left. Our solution set is now x is less than or equal to 9. And let's go ahead and write that one last time using interval notation. Again, we use negative infinity, and this time we use a square bracket with our upper bound to show that x can equal 9. Well, that's it for this video. Hopefully you're a bit more familiar with different situations you might see when solving compound inequality problems. Thanks for watching this simple math lesson.